In the previous lecture, we have learnt about the second order derivative test for maxima and minima of a function. Now today we will see the general concept of local maxima and minima, and it is called actually the nth order derivative test. Actually, this nth order derivative test for maxima and minima is just a mathematical technique used to determine the nature of critical points, and you know what is critical points and how it is found. That is a point where f dash of x is either 0 or it is undefined. Okay. Actually, in this process or in this technique, we will see that we will have to differentiate the given function successively, that is more than 2 times as needed. And after differentiating the given function in a successive manner, for each derivative of different order, we will actually evaluate the value of that derivative at the critical point. Okay. And evaluating the value at the critical point, we will be able to know that at the critical point our function is either maximum or minimum, or it is a saddle point. When you say that it is a saddle point, that means the function at that critical point is neither maximum nor minimum. Okay. Now let us learn how this process actually works. And for this we consider there is a function, let us say y, which is denoted by y equal to f of x. It means we are considering a function f which is a function of only one variable x. And this function is actually a differentiable function in a particular given interval I. Okay. And we also consider that x equal to x naught is a critical point of this function. It means when you will differentiate this function f of x one time and equate to 0, then the value of x obtained is denoted by the symbol x naught, and you know it is called critical point. Okay. Now after getting the value of critical point, let us find that when you will put x equal to x naught in the first derivative, that is when you will evaluate f dash of x naught, okay, f double dash of x naught, and in the similar manner we will obtain that the n minus 1th order derivative at the point x naught, and let us say that all these are equal to 0. What does it mean? It means if you say that n is equal to, let us say, 6, then the first order derivative, the second order derivative, and up to the fifth order derivative, all this is 0. All these are 0. But the sixth order derivative is not 0, and it is also not undefined, but it exists. If this condition is satisfied, then we can decide that x equal to x naught, our function has a local maximum or a local minimum. How this will be decided? Let us see the step. In fact, in this condition, you have to see that n is either even or odd. For example, I have considered here n is equal to 6, which is an even number. But if n is equal to, let us say, 7, then that will be an odd number. So in this condition, if the nth order derivative is not 0, but all the derivatives less than nth order, that is first order, second order, up to n minus 1th order, are 0 at the critical point, then if n is even, and the nth order derivative, that is fn at x naught, is less than 0, that is negative, then we simply say that at x equal to x naught, the function has a local maximum value. It means this critical point x equal to x naught corresponds to a local maxima of the function, and when this will take place, this will take place when n is even. Okay, but let us see, if n is even but nth order derivative is greater than 0, that is positive, then the situation is just reverse. Then this critical point x equal to x naught is a point of local minima. Okay, local minima. So these two facts are regarding n equal to even. But let us see what will happen when n is not even but it is odd. Actually, when n is odd, then this point x equal to x naught is neither a point of local maxima nor a point of local minima. Actually, this point is then called a saddle point. Okay, so this is a very simple concept. In a given problem, you have to find the successive order of derivatives of the function and evaluate all those derivatives at the critical point, and you will find that these derivatives are 0 except the nth order derivative. Okay, and then finding the value of nth order derivative, seeing that the n is either even or odd, you can easily decide that x equal to x naught corresponds a local maxima or a local minima. Okay, so these are the rules for the nth order derivative test for local maxima and local minima. Now I am taking a very simple example to clarify this idea. Let us see the example. The example says, test the following function for maxima and minima. The given function is f of x equal to x4 minus 4x cube plus 6x square minus 4x plus 1. This is your given function. And you have to test that this function is either maximum or minimum at its critical point. You have to test. So first of all, we will find the critical point of our given function. You can see this is your given function, f of x is equal to x4 minus 4x cube plus 6x square minus 4x plus 1. This is your given function. Now what we will do? First of all, we have to determine the critical point, and you have learnt about the critical point. For finding the critical point of the function, first of all, we will differentiate this function with respect to x. And this derivative I have denoted by the symbol f dash of x. This is actually the first order derivative of this function. And what will be this f dash of x? You can see the function, and this is a very simple differentiation. So when you will differentiate this equation 1 with respect to x, your result will be 4x cube minus 12x square plus 12x minus 4. Now, as we know, for critical point or when our function is either maximum or minimum, then its first order derivative is 0. So we will equate this f dash of x equal to 0. This is your second step. This is just for finding the critical point. Okay, and you can see, since f dash of x is equal to this much, which I have defined in equation 2, so you can write by taking this 4 as a common factor, that this is 4 times x cube minus 3x square plus 3x minus 1 equal to 0. But since 4 is not 0, so definitely this second factor inside the bracket will be 0. And so you can say that x cube minus 3x square plus 3x minus 1 equal to 0. And see this expression. This expression is nothing. This is simply x minus 1 to the power 3. This is x minus 1 whole cubed. Okay, and this is equal to 0. So you can say that x minus 1 is 0 and x is equal to 1. And this is the critical point. And you denote the critical point by the symbol x naught. So you can say we have obtained the value of x naught for this function, which is equal to 1. Now what will be our further steps? Now we will find the higher order derivatives of this function and evaluate those derivatives at this critical point 1. You will see that some of the higher order derivatives will be actually 0. Let us see here. First of all, we find the second order derivative, f double dash of x. And what will be f double dash of x? When you will differentiate f dash of x with respect to x, then you will get the second order derivative. So this is d dx operated on f dash of x. But we have seen that f dash of x is this much, which I have defined in equation 2. So let us substitute this expression for f dash of x. Okay. Now after differentiation, your result will be f double dash of x equal to 12x square minus 24x plus 12. Okay. Now we will put x equal to 1, which is critical point, in this equation 3. So after putting x equal to 1, f double dashed at x equal to 1 will be what? You can see the expression. This will be 12 into 1 square minus 24 into 1 plus 12. And you can see this will be simply 0. So the second order derivative of this function at the critical point x equal to 1 is 0. Now again we will further differentiate this function to get the higher order derivative. So the third order derivative, this is f triple dash of x, and that will be obtained by differentiating the second order derivative f double dash of x with respect to x. So this can be written as d dx, and f double dash of x, you can see this equation 3. F double dash of x is equal to this much. This is 12x square minus 24x plus 12. And when we will differentiate it, our result will be f triple dash of x equal to 24x minus 24. Okay. Now again put x equal to 1, which is critical point of the given function. And you can see this f triple dash at x equal to 1 will be what? This is 24 times 1 minus 24, and this is again 0. So up to this third order derivative, you can see all the derivative vanishes at x equal to 1, which is the critical point of this function. Now we obtain the fourth order derivative of this function, and you can see the expression for third order derivative. So when this f triple dash of x will be differentiated with respect to x, then we get the fourth order derivative. And what will be that? Since derivative of x will be 1, so this will be simply 24. And you can see 24 is a positive number, so it is greater than 0 for any value of x. It is independent of x. Okay. Now you can see the fourth order derivative is positive, and it is fourth order derivative. It means in this example n is equal to 4. N is equal to 4, and you have seen that f dashed at 1, f double dashed at 1, f triple dashed at 1, all these are 0. But f4 at 1 is not 0, but it is 24. It is 24, which is positive. And you have just learnt in the rule, here you can see that when f n at x equal to x naught is positive and n is even, then the point x equal to x naught correspond to local minima. So according to this rule, you can easily say that this point x equal to 1 is the point of local minimum of this function. It means at x equal to 1, our function is our function has a minimum value, okay, because n is an even number and the fourth order derivative at this critical point is positive, okay. I think after this example, the rules which we have learned for the nth order derivative of for finding the local maximum and minimum value of a function definitely has been clear to you. Actually, this concept of nth order derivative is very important, or you can say that this information is vital in various fields including mathematics, physics, engineering and economics, as it helps in optimizing functions and understanding the behavior of systems. Actually, it allows us to make informed decisions and predictions based on the characteristics of a function's critical points, okay. So after learning this nth order derivative test for maximum and minima, I will suggest you go through your textbook and solve more number of problems, and then this concept will be crystal clear to you. Thank you very much.